Good afternoon, Algebra 1 students. And any student would like to learn Algebra 1, welcome back to Mr. Chen's channel. And today I would like to talk about the lesson Chapter 5, which is System of Equation and also System of Inequality. And they're all considered linear equation and linear inequality. And once again, the reason why I'm doing this is not because for the money, okay? So it's just for fun and also especially helping out students. So it's as you can see that what I put up there on the YouTube, there's no ad, there's no advertisement, nothing like that, okay? So it's all ad free, and main part is that because I was majoring in mathematics, so I just want to help out all the students who would like to learn math in the right way, especially people that don't get access to what they're supposed to be learning in class, so they can get some kind of extra help. Okay, so also I've been doing a lot of like tutoring stuff for my school sites. Okay, and it's all free for the student. So again, and that's just my interest, or you can say that my habit. I just want to pass on whatever that I know in mathematics to all the students who would like to learn math. Okay, so you can see that my channel there has a lot of variety stuff, algebra 1 all the way up to calculus, and in the future I'm thinking about to put up like some college math stuff there as well. Okay, so check it out for chapter 5. So this one, it's a system equation and inequality. So again, we just want to go through like each sections, so you guys do have a basic idea what's happening for this whole unit. So the one that I've been using here, it's coming out from the big idea mathematics. Okay, so let's start it off with the first couple problem here. Solving system of linear equation by graphing. So for the previous unit, chapter 4 or chapter 3, it's about making a graph of a linear function. So anytime they see like a slope-intercept form, we can always define the slope and the y-intercept easily. Okay, so we started off with the x-axis and the y-axis right here. And you can always customize the scale for the x-axis, the y-axis. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And also you can use like 2, 4, 6, whatever that you like for the scale. Okay, so for the first equation here, so we do have the first slope, which is -3. And then the y-intercept, then that'd be 1. So that's called the first equation. Second equation, the slope is 1, because the number is not shown right in front of the variable, it's always 1. And the y-intercept would be -7. So started off with the first equation. So y-intercept, it's 0, 1. And then -3, which is the slope, so let's just rewrite it as rise over run form. So down 3 units, 1, 2, 3, 3 unit down, and then 1 unit to the right. Okay, so basically we just want to connect those two dots. So this one, it's an equation. So that's an equation, so that means we're using the solid line right here. So the solid line, connect those two dots. Okay, so here's what we have. And then the other equation here, so we started off with the y-intercept, -7. So -7, it's a little bit further down, so I need to extend this line a little bit further down. Okay, so let's just okay, so make the line segments a little bit further down here. Okay, so what we have, it's -3, -4, -5, -6, -7. So down here, 0, -7. And the slope here, we do have 1 unit, so 1, so rewrite it, 1 over 1. So it's up 1, 1 over to the right. Extend it, up 1, 1 over to the right. And then up 1, 1 over to the right. Okay, so basically just connect those dots right there. So let's use different color for this line right here. And again, it's a solid line. So let's just use pink. Connect them. And as you can see that the line, if I try to extend it a little bit further down, so eventually it's going to intersect with one of the point on the pink line right here. Okay, so for the blue line, I'm going to extend it a little bit further down. Okay, so this one, okay, let's just go back to that, the same color. Okay, so this one, extend it a little bit further down. So like that. So it looks like the point where they intersect, it's going to be this position. And it looks like that point right there, it's considered 1, 2, 3, 4, 5. 5 unit down, 2 unit to the right, so it's 2, negative 5. Another nice thing about this, you can always check your work. Okay, so plug in a number back to the original equation. If you do it mentally, negative 3 times 2, negative 6, plus 1, which is exactly as negative 5. And the other equation right here, 2 times 1, that's 2. Minus 7, so it's negative 5. And the other equation is pretty much the same kind of strategy. And for those students who might be getting stuck here, so just want to show you that. This one, just want to convert that from the standard form back to the slope-intercept form. So as you can see that ax plus by equals c. So this one is called the standard form of a linear function. So in order to convert that back to the slope-intercept form, we just want to convert that y, isolate that y by itself. So subtract 4x on both sides. So we got negative 2y equals negative 4x plus 6. And then divided by negative 2, divided by negative 2 both sides. So we do have y equals 2x minus 3. And as you can see that the slope here, so we got 2. Rewrite it, 2 over 1. Y-intercept, then that'll be negative 3. The first equation, the slope is given already, so that one is pretty easy to define. Okay, so the slope is negative 4, and the y-intercept is 3. Okay, so definitely you guys can try this out. Okay, so find out what that is. Sketch the graph for those two lines and find out the point where they intersect. Okay, so now let's move on to the next type of problem. So the next one here, what we found, 5.2, it's a solving system linear equation by substitution. So what that means is, so we're using one of the equations. So let's say that either you solve for y in terms of x, or you solve for x in terms of y. And whatever the expression of that variable representing, we want to put into another equation. Okay, so let's do one example like this. So 4, 5, and 6. Okay, so solve the system of linear equation by substitution and then check the solution. Okay, so let me put it to the new page right here, the new slide. Okay, so this one is too big, so let me just shrink the size a little bit. Okay, so here we go. And for number 5, okay, let's take a look at that number 5 right here, number 5. So what we got, x minus y equals 1. So that's the second equation. And then the other equation is that x plus 4y equals 6. It doesn't matter which equation that you choose as the isolation for the variable, but you always want to choose the one that looks easier, things that can be simplified easily. So the one that I would like to choose to isolate the variable would be the second equation. Because this one is very clear. There's nothing right in front of that x and y except that 1, negative 1. So solve for x in terms of y. So basically add y on both sides. So what we got here is y plus 1 equals x. So this one is still considered the second equation. Excuse me. And then what we found here, first one. So x plus 4y equals 6. So going back to the first equation. So what we found here, y plus 1, that's just exactly x. Replace x by using the binomial y plus 1. Okay, so we got y plus 1 plus 4y, so that equals 6. Again, this one is all about substitution. So as you can see that here, there's only one variable involved. So what we can do next, we can combine those variable terms together. So combine the like terms. Y plus 4y, so we got 5y. And then 1, just carry that over. And then solve for y. So subtract 1 both sides. So we got 5y equals 5. And then divided by 5. So y equals 1. Oops. Okay, let me just rewrite it. So this one looks kind of weird. So y equals 1. And then what about solving for x? Okay, so the one that we isolate the variable. So we just plug it back to the second equation. Whatever that we find out for the value of y, so plugging back to the second equation. So we got 1 plus 1, so then that'll be 2. So x equals 2. So we got 2, 1. And for those who might be wondering, how do we check the work? Well, the way to check the work, we plug in the number back to the original equation. So back to the first equation, we got 2 plus 4 times 1. Well, 4 times 1, that's 4. 4 plus 2, that's exactly 6. Check. And then the second equation here, so x minus y equals 1. So 2 minus 1, is that exactly 1? It is. So 1 equals 1. Check. So that means 2 comma 1. So that would be the right solution, the correct solution. Okay, so for the next one, it's quite similar. So you guys can try this one. Also the first one, as you can see that right here, y equals 5x plus 7. So y has been isolated already. So you can just put in that for the first equation. Okay, so now let's move on to the next part of the problem here. And let's see what we have right here. So 5.3. So for the word problem, we'll get to that once we get into the elimination. Okay, so the next section, that's elimination. So solve the system of the linear equation by eliminations and then check the solution as well. Okay, so let's do the challenging one. Okay, so let's do number 10. Okay, so again, this one is too big. So you change the size here a little bit. Okay, so now, here we go. So number 10. So anytime that you try to use the elimination technique, so you want to compare and contrast the coefficients of the variable. So coefficient, that means it's always the number right in front of the variable. So for example, like 8, 7, negative 7, 6, negative 5. So those are called the coefficients of the variable. Okay, so what we found here, so we got ax, 6x, 7y, 5y, well they have nothing in common. So right now, so you can determine whether that you want to eliminate that x or y. So in order to eliminate that x for the variable, so we want to find the least common multiples of 6 and 8. If you want to get rid of that y here, you want to find out the least common multiple of 7 and 5. So let's find the least common multiples of a and 6. Okay, least common multiple. Okay, so a and 6, even number, so that means they're all divisible by 2. So a divided by 2, that's 4. So 6 divided by 2, then that'd be 3. So 4 and 3, they have nothing in common. So once you find out things that they don't have in common, whatever the number that we have right here for the staircase method, we just want to multiply them all together. So 2 times 4 times 3, then that'll be the least common multiple of a and 6. So we got a times 3, which is 24. So in order to convert this number to 24, so we need to multiply the first equation by 3. Okay, so multiply the first equation by 3, everything. The left, the right, so we got 24x. So 3 times negative 7y, then that'd be negative 21y. Okay, so just want to change the color back to purple. Okay, so minus 21y. And then 3 times negative 3, then that'd be negative 9. And then for the second equation here, so in order to get that to 24x, so we need to multiply 6x by 4. So that means the entire equation here, we need to multiply everything by 4. So 4 times 6x, that would be 24x. 4 times negative 5y, which is negative 20y. Okay, so again, change the color back to purple. So minus 20y. And then 4 times negative 1, which is negative 4. And now what we can do here, subtract. So 24x minus 24x cancel out. So negative 21y minus negative 20y. So negative, negative, then that'll be positive. So then that'll be negative 1y. And then negative 9 minus negative 4, again, negative, negative, positive, subtract. So negative 5. And then y equals 5. So once we solve for y, and guess what we can do next? We can solve for x. So it depends on which equation that you like to use to solve for x. It doesn't really matter. Could be the first one, could be the second one. So I'll plug in the number back to the second one. So 6 times x minus 5 times 5. So that equals negative 1. Second equation. So 6x minus 25, so that equals negative 1. Add 25 both sides here, so we got 6x equals negative 1 plus 25, which is 24, divided by 6. So we got x equals 4. So 4, 5, then that would be the final solution. Again, the way to check the work, just by plugging a number back to the original equation. You can do it mentally, or you can do it showing the work. So 8 times 4, 32. 7 times 5, 35. 32 minus 35, negative 3. Check. The other one, 6 times 4, 24. 5 times 5, 25. So 24 minus 25, negative 1. So that's the correct solution here. And now, let's see what else that we have for the next section. And the next section here, it's all about solving special system of linear equation. Okay, so this one, the special one. That means it doesn't require what kind of technique that you apply. You can use elimination, you can use substitution, or you can use graphing technique to find the point where they intersect. Okay, so the other one is solving equation by graphing. So similar to what we're doing, but this one involved with absolute value. Okay, so we'll look at that. And let's go back to the word problem right here. So normally the word problem is one of the difficulty for a lot of students. So let's check it out. Okay, so number 7, back to 5.2. Okay, so let me just put it right here to the new page. Okay, so making sure that it fits for the screen here. Okay, here we go. So you spend $20 total on tubes of paint and disposal brushes for an art project. And the tubes of paint cost $4 each. Okay, so $4 each. And then the paint brushes cost 50 cents each. And you purchase twice as many brushes as tubes of paint. And how many brushes of tube of paint do you purchase? Okay, so there's a lot of information involved right here. So $20 total. Okay, so that means, well, that's how much you spend, right? So the cost for the paint brushes, well, what is that? That would be 50 cents each. And then for the tube of paint, that would be $4 each. That's pretty expensive. So the way to do it, so we need to set up 2 different results, okay? So one is the number of brushes, and the other one is the number of the tube of paint, okay? So let x be the number of brushes, and then y be the number of the tubes of paint. Okay, so now the thing is, one thing we notice, you purchase twice as many brushes as tube of paint. So that means 2 times x, so that gives you the result of y, okay? Because the statement right here, it tells you that the relationship of the number of brushes and the number of tube paints. Okay, so that would be the first equation. And then the second equation right here. Okay, so $20, so that's how much you can spend. So $4 each for the paint brushes, okay? So that means 4 times x plus the cost, well, the paint brushes is actually 50 cents each. Okay, so this one I need to fix that. So this one would be 0.5 times x. And then the other one, it's for the tube of paint, so that would be $4 each. So 4 times y. So the total amount, then that would be $20. So this one, you might be wondering what kind of method that we can apply for this. Well, definitely you want to apply substitution. The reason why that is because y has been isolated already. So you want to apply that y in terms of x. So using substitution. So what we found here, so 2x, so that's y, so 0.5x. So plus 4 times, instead of using y here, we replace y by 2x. So what we found here is 0.5x plus ax, so that equals 20. What's 0.5? X plus ax. Then that'll be 8.5x. And then you divide everything by 8.5. So 20 divided by 8.5. So what we found here, it's x. So this one, it's a fraction, but also there's a decimal involved. You can put it into the calculator. But the thing is that what happened to the calculator, I don't have a calculator now. So you can always move the decimal point from left to right, or simply multiply the top and the bottom number by 10. So then that'd be 200 over 85. You guys see that? It's the fastest way to convert the mixed number with the fraction decimal to a normal improper fraction. And then even number, well, this one is 85, so that means those two numbers, they're all divisible by 5. So 200 divided by 5, then that would be 40. Well, actually, that would be, yes, so 40. And then 85 divided by 5, so just do it mentally. So then that would be 1 times 5, that's 5. So once. And then the remainder is 3, 35, so 17. So it's 40 over 17. Now, but the thing is that this one looks like there's something wrong right here. Okay, so I would like to find out what happened with the value of x that we found. If that's the number of brushes, normally the number would be a whole number. But right now, the one that we found, it's actually a decimal. So, and you guys can put in the comment what I did wrong here. So to solve for y, we can just plug in the number back to the original equation. Okay? So check it out, the error that I made, if you guys can find out what's happening. So again, the setup, the structure, it's always reading through the statement, annotate, and then you want to set up the equation by following through the relationship of the variable. Okay? So again, I just told you that there's one of the error that I put in here. If you guys can find out what that is, put it into the comment bar. Okay? So now let's move on to the next level. Okay, so the next type of problem. So solving system of linear equation by elimination, we did it already. Solving special system of linear equation. So once you solve for the special system, as you can see that this example right here, if you plug in that negative 2x minus 6, and you end up with the number, the term got cancelled. And then the number on both sides are not considered the same. Anytime that this one happens, so that means the system has no solution at all. So that means those two lines, they never intersect. So that means there's no solution for x and y. And sometimes you'll see the exact same number on both sides. If you find out the exact same number on both sides, that means those two lines must be overlapping. And that means it could be infinitely many solutions. Okay? So try some of the practice problem from here. You'll see that the special situation for the system equation. And then solving equation by graphing. So this one we're kind of doing that earlier. And then for the absolute value, again, just make the absolute value graph and then find out the point where they intersect. So for those who might be wondering how do I make the absolute value graph, I would like to refer back to one of the chapters we talked about earlier, probably chapter 3, sketching the graph for the linear function. And then 5.6. So 5.6 is about graphing the linear inequality in two variables. Okay, let's talk about this. So this one giving you like a special condition with just one variable, and the one that involved with two variables. Okay, so let's talk about this one. Okay, so again, just need to shrink the size here. Make it smaller. Okay, so now started off with y, it's greater than negative 4. So on the xy plane, if you try to sketch the graph of y, it's greater than negative 4. So we got the x-axis, the y-axis. So y is greater than negative 4, so let's allocate that position negative 4, so it's down here on the y-intercept. And now there's no equal sign involved. If there's no equal sign involved, that means the line must be dotted. Okay, so dotted, not solid. Okay, and negative 4 right here. And now you might be wondering, well, it's greater than, well, according to the rule for greater than. So anytime that you see anything that's greater than, so that means it's either above the line or it's on the right hand side of the line. Okay, so anything that's above. So that means you need to shade this area over here. So that means in this region, you'll find out all the solution for y is greater than negative 4. There's so many solutions involved. It could be negative 3, it could be negative 2, it could be negative 3.5, it could be negative 2.5, it could be negative 1.5. And also it could be 0, or obviously it could be positive number. Okay? So now, what about for 18? So number 18, so this one is written as kind of like a standard form of a linear equation. But this one is an inequality. And also that involved with the equal sign. So first thing that you want to do, you want to isolate that y by itself. So at 9x on both sides. And then what we found here is 3y, it's greater than or equal to 9x plus 3. And then divide both sides by 3. So what we found here, y is greater than or equal to 3x plus 1. Again, making a graph. Okay, so this one, so I need a solid line here. Okay, so the solid line. Okay, so let's see, right here. Okay, so y-intercept. So start with the y-intercept at 1. Excuse me for a second. So start with the y-intercept at 1. And then the slope. So the slope is considered 3 over 1. So up 3 units, 1, 2, 3, 1 over to the right. And then basically we just connect those two dots. Okay, so this one, there's an equal sign involved. So that means it's a solid straight line. Connect them. And now this one is saying that it's greater than or equal to 3x plus 1. So if that's greater than, as what I mentioned before, it's either above the line or in the right hand side of the line. So above. So that means the area over here is right above the line. So that means in this region, you'll get all the solution for this inequality. Okay, so now let's see what else that we have from the template. Okay, so back to the slide here. So the other one is a little bit more complicated. It's a system of linear inequalities. Okay, so we'll take a look at that. Okay, so again, just want to copy and paste the slide here. So check it out, that 20 through 22. So we'll do the challenging one. Okay, so again, just want to make the size, shrink the size here. Okay, so check it out, 22. So what we found here, we do have two inequalities. So the whole thing is called the system of linear inequality. Because the highest power, it's 1. That's why it's called a linear. So we got x plus 3y, it's greater than 6. So again, the first step, we need to isolate that y by itself. So what we can do, subtract x on both sides. So we got 3y, it's greater than negative x plus 6. And then divided by 3 on both sides. Now got to be very careful right here. The number right in front of that, negative 1, in front of that x right here. So that's negative 1. So we got y, it's greater than negative 1/3 x plus 2. As you can see that here, I just separated the fractions and the variable. So that just takes care of the first inequality. And what about the second inequality? So basically we want to do the same thing. Isolate y by itself. So 2x plus y, it's less than 7. So this one is a whole lot easier compared to the previous one. So what we can do, we can just subtract 2x on both sides. So subtract 2x, so we got y, it's less than negative 2x plus 7. So that would be the second inequality. So again, define the slope and the y-intercept. So the first one, we got negative 1/3, rise over run. And the y-intercept here, we got 2. Second inequality, so we got a slope here, negative 2 over 1. And the y-intercept is 7. And then making a graph for the line. Okay, so I need the line special 2 bar here. Okay, so we need the x-axis and the y-axis. Okay, so started off with the y-intercept, so it's 2 units up. And the slope here, negative 1 over 3. So negative 1 unit down, 3 over to the right. So it goes over here. And then basically connect those 2 dots, so it's inequality. And this one, there's no equal sign involved. So that means the line must be dotted or dash. Okay, going this way. Okay, so that's just take care of that, the basic structure of the first inequality. Another thing that we need to find out is that the shaded area greater than. If that's greater than, so that means it's right above the line. Okay, so in this area, for this inequality. And what about the other inequality? So similar, so this one is 7 units up. So 7 units. So 1, 2, 3, 4, 5, 6, just keep going, 7 right here. And then what we found here, the slope, it's negative 2 over 1. So 2 units back down, 1 over to the right. 2 units down, 1 over to the right. Okay, so basically connect those dots. Again, this one, there's no equal sign involved, so that means it's also dashed or dotted. Okay, so going this way. So you might be wondering, do we just find the point where they intersect? Well, this one is no longer finding the point where they intersect. It's about finding the area where that they're being intersect. The area that they overlap. Okay, so the other line right here, so it's less than. So if that's less than, so that means in this region. Okay, so I don't want to use purple, I want to use different color here. Green. Okay, so let's see. So in this region, so that means it would be the solution for this inequality. As you can see that right here. The overlapping region, the overlapping shaded region, so that would be the solution where you can find. Okay, in this region. Okay, in this area, all the way. So get all the solution. So just highlight it, all solutions. Could be found in this region. And also you can always choose the point, plug in a number, and then just verify it. So let's say that you pick 0, 0, 5. So plug in a number. Is that in that region? 0. So that would be 0 plus 2. So which is 2. So 5 is greater than 2. And then over here, 5, negative 2 times 0, which is 0. So 5, it's less than 7. So you can choose any kind of xy value in this area to check your work. Okay, so any questions, comment, concern that you have, so feel free to put into the YouTube comment bar. So I'm more than happy to have those kind of answer for you. Again, the error that I made earlier for the word problem, if you guys can find out what that is, so you're more than welcome to put in that to the comment bar on YouTube. So thank you for watching the video today. So I'll see you guys next time. Take care.